Hello, and welcome to my attempt to give an intuitive sense of LLMs without using any math. So, why did I make this? Well, I've been doing machine learning for a large part of my life, and people make it out to be like the internals of machine learning are too complicated to understand, and that there's no intuitive explanation for it, and it's unexplainable. So like let's not go into it. But and I do agree that there's a lot of problems with explainability, but I don't think it's impossible. And I think treating it as impossible is actually worse than giving a bad explanation. I think if we see LLMs as being these black boxes that are just trained stochastically and that there's no way to see what's actually going on inside, we have the wrong impression of what these technologies actually are. They are running on computer systems. We can inspect them just like we can any other computer system out there. We can modify its internals. And I actually think that somewhere in the future, modifying the internal weights inside LLMs is going to be the way to go instead of going through very messy trainings. So I think the very first step in all of this is unlearning this whole black box idea. So, and trying to get an intuition of what's actually happening inside. So this is my attempt to give that with an explanation that hopefully makes some kind of sense. So yes, welcome. You're now an LLM. So I will give you a shockingly tiny number of tools that you'll use to reason about the world and about human language. These tools are going to seem very random and arbitrary because they are. They exist as they do because humans have worked out some really crazy math to make these tools work really, really well. The first tool that you'll get is a slider. And it's the same as like a slider that you'd use to control volume or music or something like that. You can set it to any number between minus 65,504 and positive 65,504. And actually, here's 10,000 of them. I only drew 3, but you can use your imagination and you can imagine that there's 10,000 sliders. And that's pretty much it. So you have 10,000 sliders to understand the universe basically and describe it back to us. Here you go. Your first question and the most obvious question is, what do these sliders mean? Well, they mean whatever you want them to mean. So in this case, this slider is a spectrum between cute and ugly. And here's a couple more sliders. This one is a spectrum between hairless on the bottom and furry on top. This last one is between not being a noun and a noun. And again, these aren't binary values. You can set them to anything between minus 65,000, positive 65,000. And we can change what these mean later. And in fact, we're going to have to. But for now, we'll run with this. These same sliders have different issues. So sometimes we use these sliders to keep track of words. So we keep track of the word we just saw or a word that we saw previously. Sometimes we use it to keep track of sort of the internal state of the universe. So sort of a mental model of what's going on right now. But yeah, they're used for everything, but it's basically the same sliders. Let's start with words. So here's another tool that you get. It's a word to slider dictionary. So this dictionary basically has entries in it where you see a normal word written out like we would have, and then you get the slider values for that word. So let's imagine the entry for hairball. In this case, the ugly cute slider is set to ugly. The furry slider is set to quite high because it's quite furry. And the noun slider is set pretty high as well because hairball is usually a noun. An entry for cat. It's very similar to the entry for hairball, except there's more cute in this. And again, these are just arbitrary, but just imagine that this word to slider dictionary just has tons of these entries inside of it. So let's go ahead and read our first word in. Oh, hey, it's cat, because I didn't want to make another slide. So we have cat, and we find the entry inside the word to slider dictionary, and we set the sliders to that. So that's what a cat is. The next step is we get a context dictionary. So unlike the embeddings or like the word entries that we had before, this dictionary outputs a change to the sliders. So whatever setting we had on the sliders, this says, for instance, if we have cat in the context dictionary, it says whatever settings you have to the sliders overall, bump up the cuteness and bump up the memeness. And this is kind of important. Oh, looks like my face is cutting this off, but this is kind of important. So the entries in the context dictionary are across the same sliders, but they're not the same as the entries in the embedding dictionary or in the word dictionary. They're usually related in some way, but they're not the same. The point of this context dictionary here is, what does the word here add to the overall context? So if we're using this set of sliders to describe the world as it is right now, or our understanding of the world as it is right now, what does this word in particular add or subtract or change to our understanding of the world? So in this case, we know a cat is very furry, but that doesn't mean that just because we see the word cat that we're in a very furry world. However, seeing the word cat does increase the chances that the whole document is a meme, because cats are in memes. So this is the kind of information that we're getting here from this dictionary. And these changes are also cumulative. So across every single word that we've seen so far, and the position of the word, but we can kind of ignore that for now. Across every single word that we've seen so far, we get different changes to the sliders, bump them up, bump them down, and we add all that together to get sort of a context of where we are right now. So this shows the context that we're in right now. So we're at a high level of cute, a neutral level of furry, neutral level of noun, and a high level of meme. Just as a check here, do you understand why furry and noun are low despite them being high in the entry for cat? Just to go back over here, in this entry for cat, we show those as being high, but in the context entry, we show them as being low. Again, it's because we use the slider entry for cat to find the slider entry for context. And then we say, oh, a cat adds these things to context, so let's just add these things. And yeah, go ahead and go back if that doesn't make sense. An interesting note here, this context, there's no memory here. So we could have seen the first word, we could have seen one word or like 1,000 words already. Each word has an impact on sort of this final setting. But yeah, in the end, it's all squished down to sort of a single view of what the context looks like right now. And like I said, just for completion's sake, the order of words is also encoded in here, but we're going to skip over that. The next step is applying some sort of rules. So we can imagine that we have a rule book here, and we interpret this stage as applying the rules that we've learned given a state in the sliders. So in this case, we see in context that hairless, like if hairless is very high, then set cute to 0, for instance. If cute and meme are very high, set noun to low, just as an example. And some important things, these rules are applied to the context as we see them right now. They're applied all at once, and they're also applied only once. So, the rules can't get super complicated and reapply into each other or anything like that. They're just applied at once, and they're applied one time to the whole context. Really, each one of these quote-unquote rules impacts all the sliders in many ways, but for illustration and for explanation purposes, we're going to say that the rules impact certain sliders and not others. But yeah, so in this case, if we had a rule, if cute and a meme set noun to low, we do that. The final step now is we have a bunch of sliders set to a whole bunch of different things. Let's go back to our word to slider dictionary and find out what word this maps to. Except we see that it doesn't map to a single word because, again, these things aren't binary. Like they can be set to whatever value. So whatever this context is that we're seeing, this context with the rules applied, it's going to map out to different words with different chances of mapping out to those words. So again, sorry for the lack of creativity here, but the examples for being high on the meme, not so much a noun, medium amount of furry and cute, maybe the word that we're going to output is meow. Maybe the word is going to be nom nom. Maybe it's going to be nyan. Maybe it's going to be burger with different amounts of probability. But this is what we get when we do the word to slider dictionary this way around. We don't actually get a single word. We get a bunch of words that are close to describing the situation that we see right now. And again, this is a feature, not a bug. This is how we get creativity out of LLMs. This value is sometimes referred to as temperature. And what we basically say is once in a while, give us less likely words, especially when the words are close. So when we see something like this, in our example, we see that meow is very, very likely, but maybe we want the LLM to be a little bit creative and pull something that's less likely every once in a while. And those words, once these words are output, they go back through the whole system the same way. Like the LLM doesn't care if you wrote the word or it wrote the word. It processes the whole word sort of the same way. But this sort of randomness right here of the fact that sometimes we say don't pick the top word, that's why conversations with LLMs don't always go the exact same way, even if you've said the exact same things, because we add like that randomness to it. We don't have to. We can also do LLMs where it only picks the top word every single time, but just sort of pragmatically, when we do that, the conversations don't end up being as useful. They end up being kind of stale, and a lot of the times they just reproduce things that the LLM has seen. So we generally don't do that, but just because we don't do that doesn't mean it's impossible. And just because we don't do that also doesn't mean that we can't make this be sort of stochastic, where every single time you type something in, you get the exact same thing back out. It's a choice that we made. It's not just the magic of how this works. So let's give a full overview over here. So we have an input. We have a word to slider dictionary. We set the sliders to something. Then we have a context dictionary. We take all the words and their slider entries from the context dictionary, and we move the sliders around based on that. We have this single view, and then we pass that through into a rule book that changes the sliders around based on different rules that's learned. And then finally, we go back to the word to slider dictionary and find the words that are closest to what situation we have right now. And there's an asterisk here, because there's always an asterisk. There are several places where the sliders are readjusted. I just left them out for simplicity because, again, they're basically every single time that we pass them somewhere, the sliders are readjusted. There's weights and biases applied throughout. And here, just so you know what these things are actually called, so you're not going around talking about slider dictionaries and stuff. The first thing is called word embeddings. Those are that's the mapping of words to these slider settings, which are just vectors. This next step is called self-attention. That's where we pick how much each one of those word embeddings impacts sort of like the overall situation. And it's kind of like the way that it's usually described is we're picking the words to pay attention to. But I think describing a context is a little bit better. And then finally, there's a feed-forward network, and this is the network that has different like neural activations. But like in practice, what happens at the end is you kind of get these rules that have been learned, and that those rules are applied. Finally, there is if we want to think about how these rules are learned, we can talk about the learning steps. When training the LLM, we look at the probabilities output. So if we go back a couple of slides here, we have the fact that words are output as probabilities. So we look at those probabilities right there. And we basically say, this was the real word. This is the word that, you should have predicted, but you didn't. And then we send that information back to it saying, okay, these, like you should have predicted this word at 100%, but you predicted 60 or 70, adjust everything accordingly. And this part, I do have to do a little hand wavy math here. The math is what makes it easy to send that information back through all of the systems and have them update, including the dictionaries, have them all change and adjust themselves a tiny bit based on that word and try again. So after doing this over and over and over again, these dictionaries start to settle and we get a large language model. And an important note here also is that after it's been trained and it's ready for you to interact with it, none of those dictionaries are updated. So when you're talking with it, it doesn't learn anything while you're talking with it. It's frozen the way that it is. So except for the words that you've fed it in that particular conversation, it's frozen. The only way for it to learn is to go back through this training process the next time around, which some companies do. Some companies take the data that you've given and train it again, but like that process has to happen sort of offline. It doesn't just automatically update here. So let's talk about those categories for a minute, because the whole key to being able to interpret what's happening in an LLM is understanding those labels and what those labels mean. If we know what they mean, then everything is it's a lot easier to make sense of things if we know what they mean. But the truth is the LLM doesn't label the sliders. We have to infer the labels by looking at the data. And the labels are not clean in any way either. Like just, as a practical example, when you look, a single label could be like the top of the slider could mean this is most likely a city in Europe, or it's a number ending in 8, or it's a French term for pastry, or all of those things at the same time. So a lot of the critics of interpretability talk about the fact that, again, these aren't clean categories. It hasn't created clean categories. And again, it doesn't label itself. So these labels are something that we as humans looking at the data have to say, okay, this is kind of what this is. And there is also some debate about whether those labels mean the same thing as it's traveling through the various stages, and whether it makes sense to interpret everything the same way as it's moving through the stages. But still, despite those difficulties, I think that the alternative of treating it as completely impossible and this huge black box that has no meaning whatsoever is much worse for discourse, because then we just have to accept that it's like random dice or something that are being rolled inside of it, or as I've heard many times, it's just an autocomplete. But what does that even really mean? These systems are changing the world, and we shouldn't shy away from understanding them just because it's mathematically convenient, but otherwise sort of haphazard and it's difficult. So I'm sure people will have issues with the way that I have explained this. Good. Let's start that dialogue. Let's not just have them be, random things that are just impossible to understand. And yeah, I skipped over a lot of the math, but I think that it's more important to have some intuition of what's going on as opposed to like knowing the math exactly. So yeah, if this was useful potentially for next time, I can go into a little bit more depth about the implications of this architecture, so we can think about what LLMs can and can't know, and also just some of the strange prompting advice that I see that obviously doesn't make sense even with this level of understanding. So yeah, hopefully this has been useful, and yeah, bye.